All right, so first thing we're going to do here is solve these two bell ringers. Now, in today's notes, what we're going to do is we're just going to focus on simplifying our square roots. This is just a review of something that you had done in Algebra 1 and in geometry, but we're now going to use this in our uh, quadratic equation solving stuff. So let's just go over what we did there in 5.5. So remember, our first step is we want to make this equal to 0. So I need to subtract 18x from both sides. So I'll subtract it from both sides. Now remember, we cannot combine this with the 6x squared because they don't have the same exponent. So I want to write these next to each other. So 6x squared minus 18x equals 0. My right hand side, everything cancels. I'm just left with 0. Now I'm going to go through my process of solving this equation. So basically what I look for is now I want to see, do I have a GCF? Remember, if you have a number of a GCF, we divide that out. So these are both divisible by 6, and I will go ahead and divide 0 by 6. That will just give me 0, but mathematically we need to make sure we are still showing that. 6 divided by 6 is 1, so I have 1x squared, minus 18 divided by 6 is 3, so I have a 3, and I still have this x here, so 3x, equals 0 divided by 6 is 0. If you have a variable that is part of your greatest common factor, we don't divide that because that would be dividing by 0, which is a no-no. We can't do that, so we will factor that out front. X times x minus 3. So I will divide the x out front. They both have an x, so I pull that out front, factor it out. What am I left with? Well, if I start with x squared and I divide by x, I'm left with an x. And if I start with a 3x and I divide by x, I'm left with a 3. So you can just jump right to your answers here, or we can set them up. So this is where it's being multiplied. So that means we will have two parts, x equals 0, or x minus 3 equals 0. This one is already done. We don't have anything to do there. Over here, to get the x by itself, you could probably do this in your head, but again, I'll just show you what's happening there. Oops. We have x equals 3. I got an extra line there for my equal sign, so x equals 3. There's my other answer. Okay? Next up, again, same process here to begin with. We want this equal to 0. So subtract 11x, subtract 11x, and we want to make sure that we put that in line where it belongs in descending order, standard form. They all mean the same thing. We need to go highest power down to lowest power. So first up, oops, dragging my pen. All right, first up we have 3x squared, and then the negative 11x will go next, plus 10, and that is equal to 0. So we want to see if we have a GCF. Excuse me. We have no GCF here, okay? There's no number that will divide out of all of these, and there is no variable that we can take out. So we're going to do our factoring method. And again, I prefer to use this, what is referred to as the magic X method. So that's what I'll use. So multiply your outside. 3 times 10 is 30. That goes up top. The middle number is a negative 11, and that will go at the bottom. So negative 11 goes down here. Then what we want to do is try to find two numbers that will multiply to give me 30 and add to give me negative 11. So that is a negative 5 and a negative 6. Last step, we want to divide by 3, so we'll divide both sides by 3. If it does not factor, like this first term here, we'll put that in parentheses. Remember, the x goes with the bottom. So 3x minus 5, there's my first factor. This fraction over here, these are both divisible by 3, so I'm going to divide a negative 2. I'm going to divide a 3 and be left with a negative 2 and a 1. So this factor looks like x minus 2 equals 0. So now I'm left with something like this here where I have to set up my two parts. So either 3x minus 5 equals 0, or I know that x minus 2 is equal to 0. Solve them in as many steps as it takes you. This one over here is just a one step, so let's start with that guy. So add 2 to both sides. I get an x equals 2. There's one answer. And over here we have 2 steps. Add 5 to both sides. We'll do that first. Negative 5 plus 5 is 0. Those are gone. 3x equals 5. And then we want to divide by 3 for our final answer. Do not write this as a decimal. Leave it as a fraction, 5 over 3. There we go. And also I want to remind you that we want to get away from mixed numbers. We want to leave everything in improper fractions for pre-calc. So make sure that you are leaving that as 5/3. Alright, now getting into our simplifying square roots. You have a couple different ways you can do this. Probably in Algebra 1 you did a factor tree. Anytime you saw a pair you pulled that out, multiply the numbers on the outside, multiply the remaining numbers under the square root, and you most likely went through it like that. For pre-calc, you are still welcome to do that method, but you can also just look for perfect squares and separate it. So I'll show you what I'm talking about here in number 1 and number 2. It'll be entirely up to you how you want to handle these problems. Again, you've already done these before. This is just a review, making sure that you remember how to do them. So first of all, I'm going to follow this process here. So make a factor tree. I need to find 2 numbers other than 1, 2 numbers that will multiply to give me 75. So that is 3 and 25. 3 is prime, so we cannot reduce that any further. 25 is 5 times 5. Now, one thing that students always try to do is they always want to take this down to prime numbers. That's not wrong to do, but a lot of times that's creating extra work. Because remember, our process here is looking for pairs. Once we have a pair of numbers, that number comes out as a single. So I'm going to take that 5 out. I had 2 5s, that'll come out as a single 5. Anything left over stays underneath your radical, or in this case, square root. And that's not a 5, that's a 3. My bad, back up a step. Let's write down the correct number here, 3. There we go. So there is your final answer, doing it using this method right here. The other way is if you look at 75 and you notice that you have a perfect square in there, divide it out. So what I mean is we can separate this as the square root of 25 times the square root of 3, because 25 times 3 is 75. And then I know that the square root of 25 is 5. Square root of 3, we'll leave that as square root of 3. That gives us an ugly decimal. We don't want to do anything with it. So we want our answers to be exact, so square root of 3 is exact. All right, number 2, we have a negative here. Okay, so that negative will be part of our answer, so we don't want to forget about that. All right. Also, at any point in time during this video, if you need to slow down, pause the video, rewind, do any of that stuff, you know, you guys probably already do that anyway because you've watched a video before and you know that that exists. So you can pause, rewind, do whatever. Even if you want to pause, try the problem, and then fast forward to the answer and see if you get it correct, you know, go ahead and do that too. So I'm going to try this method right here with the square root of 32. Now we want to think of some perfect squares in 32. So let's think about our perfect squares. 1, we don't really worry about 1 because 1 does not change a number when we're multiplying or dividing. The next perfect square is 4. So I know I have 4 as an option. So let's go through some more. 3 squared is 9. Well, I can't divide 9 out of 32. 4 squared is 16. Well, I can take a 16 out of there, so 16 is also an option. And those are the only 2 options that we have. Okay, 5 squared is 25, 6 squared is 36, so those are already too big. So I want to look for the biggest perfect square, so 16 will work. So this is negative square root of 16 times square root of 2, because 16 times 2 gives me 32. I also know that the square root of 16 is 4, so my final answer is negative 4 square root of 2. Okay? Now some of you may be looking at that and thinking, I have no idea what's happening there. That's okay. Let's just do the factor tree for those of you that are more comfortable doing that. We need to look for a number that is divisible by 32. So let's say you're not too familiar with it, but you do recognize it's even, so it's divisible by 2. So 2 and 16. 2 is prime, so we'll let that go. 16, though, let's see, I know 16 is 4 and 4, but I also know that it's 8 and 2. So I'm going to do the 8 and 2 just because, just to mix it up. Now, I already see that I have a pair. I have a pair of 2s right here. So that will come out as a single 2. Okay? And also, we don't want to forget that we have a negative there too, so I'll bring that with it. All right, I'm coming back to my factor tree now. Sorry, I'm jumping all over the place. Hopefully you can follow me. 8 has 2 factors, 4 and 2. All right, I'm not finished yet. 2 is prime, but 4 is 2 times 2. All right, now, your pairs, and that's why I did it this way, your pairs do not have to be right next to each other. A lot of times when people do these, they want to look and say, well, these are a pair because they're right next to each other. But that is no different than if you were to say, well, I have a pair of 2s, I have a 2 right here and a 2 right here. It's the same thing, okay? So they don't have to be right next to each other. You just need 2 of them to bring one out. This 2 right here did not have a pair, so that will stay underneath the radical. Multiply. Negative 2 times 2 is, you guessed it, negative 4. That was our answer. We already knew that. And we had a square root of 2 that could not simplify, so there's your final answer. And again, that's done 2 different ways. You pick your favorite way. It doesn't matter. Just show me what you're doing so I know your thought process. Okay? So there you go. There's 2 different ways of doing it. All right, next. Number 3 and number 4. We got 2 more after this that we'll talk about. Now, when you're doing these, you want to make sure that you don't forget about the number that is out front. Just like in the last one, we had a negative. This has a 5 and this has a 7, so they are part of our answer. So don't forget about them. All right, so what I do typically, so I don't forget, is I'm going to rewrite that, and then when I simplify my 320, I'll bring out the other factors and multiply it by 5. So that's my thought process here. Okay, I'm going to do the factor tree. So I'm going to start with 10 and 32 because 320 ends in a 0. I know it's divisible by 10, so that helps me to bring the numbers down to smaller, more manageable terms. So 10 is 2 times 5. I don't have any pairs yet, so they're going to stay the way they are. 32, I know that's 8 times 4. 8, I know is, 8, oh, come on. 8 is 2 times 4. Okay. And, sorry, I'm trying to make this screen back to normal. There we go. All right, so now when you get to this step, excuse me, when you get to this step, we don't have to take the 4s down to 2 times 2 because remember, our goal is to look for a pair. I have a pair of 4s right there, so bring the 4 out. I also have a pair of 2s. So those 2s will come out as a single 2. And then I got this little 5 right here that does not have a pair, and that will stay underneath. Now we multiply. 5 times 4 is 20. 20 times 2 is 40. Square root of 5. There's my final answer. Next problem. Again, I'm going to recopy this 7 so I don't forget about it. And actually, let me just move this whole thing over so I have more space to work it out. I'm going to rewrite this 7 here. All right, 108. Now, 108 might be one of those numbers that you're not too familiar with. No problem. It's even, so I know it's divisible by, you guessed it, 2. So 2 goes into 108 54 times. Now you might be looking at 54 and trying to think, all right, I don't know what I can do with that. So again, it's even, so you can divide it by 2. Or maybe you recognize that it's 9 times 6. I still don't have any pairs yet. 9 is 3 times 3. 6 is 2 times 3. So let's look for my pairs now. Well, I have a 2 right here with a 2 right here. So they will come out as a 2, one single 2. I also have a pair of 3s. Again, I'm choosing the 2 3s that are right next to each other, but they don't have to be. You could have chose this one and this one. Okay? It doesn't matter. They don't have to be right next to each other. You just need a pair. So keep that in mind. Whoops. I erased too much. Alright, so that pair of 3s will come out as a single 3. And I got this little 3 here left over that will stay underneath the square root. So I'm ready to multiply. 7 times 2 is 14. 14 times 3 is 42. Square root of 3. Final answer. Number 5 and number 6. Now these are the last two that we're going to do. These two problems, when you see the square root of a division like that, or a fraction, this is the same thing as doing square root of 5 divided by square root of 3. And this is something, I don't know if you've ever seen this before or not, so this part might not be a review to you. But in Algebra 2, what we want to do is we want to get the square root out of the denominator. So the way that we do that is by multiplying by whatever is in the denominator. So the denominator here is a square root of 3. So we're going to multiply that. Square root of 3 times square root of 3. But remember, whatever we do on the bottom here, we got to do it to the top. So it's equal to 1. So let's multiply these. Square root of 5 times square root of 3 is, multiply the numbers underneath, square root of 15. On the denominator, square root of 3 times square root of 3 is, 3 times 3 is 9. So the numerator does not simplify. That's square root of 15. But on the denominator, what's the square root of 9? Think about it. What's the square root of 9? Well, that's just 3. So there's your, whoops, I kind of missed the mark there. Let's try that one again. So there's your final answer. There we go. Okay, number 6. I'm going to do a negative. It doesn't matter where we put the negative. It can be up top, out front, or on the denominator. It doesn't make a difference. I'm going to split that up first. Negative square root of 7 over square root of 5. Multiply by the denominator, so square root of 5 over square root of 5. Put the negative out front. Square root of 7 times square root of 5. Again, multiply the numbers underneath. 7 times 5 is 35. Square root of 5 times square root of 5. Square root. 5 times 5 is 25. And then again, square root of 35 does not reduce. Don't forget your negative out front. Negative square root of 35. But the square root of 25 just gives me 5. Alright, so there's your final answer for the last example. Okay, so again, if you have any questions on any of this, or you need to rewatch it, go ahead, rewind, and do all that. But if you do still have any questions, just let me know.